And coming up next, we have someone I would have to say is essentially just like me because he's got almost the exact same credentials on LinkedIn. This is Benjamin Bischoff. He's a conference speaker. He's a software development engineer in test. He's an author. He is a magician as well. I did that terribly. My French shop is a little bit better. Nice, nice. And yeah, he speaks at conferences, and he also has a book. He's writing API tests with karate. I have been dying to get into karate for like 5, 6 years since it first came out, and I highly recommend that book. Um, so Benjamin is on screen over here. Hey Ben, how you doing?
Hello, I'm doing great. Glad to be here. How are you?
I'm doing great. I'm having a ton of fun playing around with some low code test automation tools. Test Rigger is one of them I'm playing with right now, where I just have to click the add to cart button, and it figures out where it is. A lot of generative AI stuff in there. I might actually do a session in a couple of upcoming months. But enough of that. That there, Ben. Why don't you tell us a little bit about yourself and start the presentation? We'll have some questions at the end.
All right. Yeah. My presentation is shared. Yes. Wonderful. So you see it there. So hello to everyone. Of course, I'm here in Germany, but hello to you wherever you are in what time zone you currently are. The topic now is identifying code smells. It is honestly quite tough to follow a great live coding presentation as we had before, but I'll try. So, yes, identifying code smells, that is the topic. But first, let's get me uh, out of the way here. My name is Benjamin Bischoff. I'm a test automation engineer at trivago in Germany. You might have heard of trivago. If not, that's okay, because that is not the topic right now. I've been 23 years in IT, first 15 years as a full-time 100% developer, and then I gradually slid into the testing world. And last 8 years, I've been a software development engineer in test, which is much nicer, I have to say. But this is also the reason why this topic is so close to my heart, because I have been a developer. I have used all of these techniques in finding code smells. So whenever I write test code, I have those in mind. Yeah, like was mentioned, shameless plug. I also wrote a book. This is the book, Writing API Tests with Karate, about the Karate API framework. It's been out since last year, and yeah, if you are interested, please get it. A little disclaimer here. Um, this talk is only about the identification of code smells, not how to fix them. I will show you some resources in the end that can help you to fix code smells when you encounter them, and also tooling that you can use to find them. I will show lots of code, and it's going to be all in Java because Java is still the language I hate the least. Sorry for all the Python programmers, but I chose code that should be quite easy to understand, and I will also point out the relevant lines when we get there. Yeah, this is a slide just for me. When I prepare a talk, I like to just insert a slide that I think is funny. Smelly coat, smelly coat. If you don't know the reference of this, you're either too young or too old. Um, I can tell you it's from the TV series Friends. And if you, hey, Paul knows it. Uh, if you don't find it funny, I'm very sorry. I think it's funny. But let's dive into the topic now. The term code smells, where did it actually originate? And it was in this book, Refactoring, written by Martin Fowler together with Kent Beck. And you can see here, this is the second edition of the book with a quote of Martin Fowler from 1999. So even the second edition of the book is already 25 years old. But that doesn't mean it's not relevant anymore. Oh, I see there is a magician there in the chat. Hello, fellow magician friends. All right. The way they describe code smells in the book is that a code smell is a surface indication that usually corresponds to a deeper problem in the system. And the key word here is usually, because it doesn't have to point to a problem, it can point to a problem. It all depends on the context, on your coding style, on the guidelines of your team. So a code smell is just something when you look at code, you you have this gut feeling that something might be off here. So why should you care about this at all if it might just be a problem, but it doesn't have to be? Well, first thing is communication. Whether you are a developer, a tester, somewhere in between, like my role, you need to speak a common language. And if you can show someone a piece of code and say, "Yeah, I think there's this code smell in there," instead of, "I think there's something wrong with this." This helps a lot if people can just understand what you're talking about. It is also a step towards better code. If you combine that with clean code principles, design patterns, and these techniques and methodologies, it can make your code much, much better, or the code of someone else if you are reviewing code. It also leads to less technical debt. Technical debt is something that when you develop code, leaves something to be fixed later, and this can pile up in the future. So it's better to avoid problematic code early in the process instead of fixing it later. And also, of course, since this is a test automation meetup, testability. That's a key thing because testable code is maintainable code. And the better the code is, the better its testability becomes. And this also applies when working with AI. This is a slide I added because of the talk before mine. Whenever you talk to a tool like ChatGPT or Copilot, you get code generated, and this also makes sense to know when there might be code smells in the generated code. So just not blindly accept what those tools give you, but if you see something, you can also talk back to it saying, I think there is this code smell in there, and then ChatGPT will make it better for you. This is also what was mentioned in the talk before. It's always good when you know something about the things that you want to get from ChatGPT. Well, there was a problem with this book. They listed a lot of code smells in there, but they were not really sorted and grouped and categorized. So it was not that easy to pinpoint certain code smells in the book. So that's why there was this taxonomy of code smells paper that has been written by those two people that I will not dare to to try and pronounce, from the Helsinki University of Technology, and they actually devised this categories and taxonomy of code smells. And this is what they came up with in the papers. And I don't want to scare you, but we will go through all of those. I will show you example code for all of them. But please bear with me. I think there's some fun examples in there. So let's start with the first category here, which is called bloaters. And a bloater is something in the code that is too large to handle. And as you will see in this first code smell, it doesn't mean that you have a lot of code if you have a bloater. This specific code smell is called long method, and that is a method that does too much. Again, I will point out the relevant lines so you don't have to try to understand the whole thing at first glance. It is about this method, save customer. Let's imagine we have a webshop class and the save customer method that we pass a customer into. And this will save the customer in some way. In this case, I just added it to a list. But as you see down here, it does something strange. It returns a string saying we have a new customer called, and then it prints out the customer name. Um, at first glance, you may think, okay, this is not bad, but it is actually a method that does too much. It doesn't only save a customer, it also prints this string, we have a new customer. And this is something that a user of the save customer method would not expect. Also, it returns this value as a string, which is also weird for a save customer method. So it shouldn't return anything, or it should return the customer object, but dealing with a string is kind of strange. So this method is just doing too much out of its scope. The same thing can apply to classes and the methods within a class. So here I have a shopping cart class, and there are some methods like add product, remove product, and checkout that clearly belong to a shopping cart. But if you look at those, enter voucher code is not necessarily a part of the shopping cart itself, and contact support is clearly out of scope here, and that should be in a separate class. So this also is a code smell in the bloaters category, which is called large class. That simply means a class that does too much, a class that does things that are out of its scope. Another one is primitive obsession, which refers to primitive types that you don't have in all of the programming languages, but you have them in Java, for example. And this is a code smell. It doesn't look like one. It just specifies a zip code as an integer, but this integer zip code can be a zero, it can be a negative zip code. It you have zip codes that contain letters. We don't have those here in Germany, but there are countries that also have letters in the zip code, and this has no validation at all. And you see that this method, this customer, also has an age, which is also an integer. So that could get confusing for the user of this. They might mix up the age and the zip code. So there are actually a lot of problems in this tiny line of code. But again, it doesn't mean that it is bad. It just means that it can be bad. It's just a smell. The long parameter list is definitely something I have done before, and probably every developer has done. It just means you have too many parameters in a method. Here in the calculate result method of some example class, it doesn't matter what this is doing exactly. This accepts a lot of parameters, like a base value, a boolean that's called isMetric, another boolean that says is 2D, an integer which is an offset, and an integer um, that can be null if you know a little bit about Java. So 5 parameters, that doesn't look that bad when you look at it first. But when you want to use this method, you can see that there is something off because he would use it like this: calculate result, for example, 13 false, true, -1 null. If you don't have hints from your IDE, there is no way to really know if you're using this correctly or what the parameter combination is doing. And also, this is a nightmare to test. Imagine covering that with unit tests, all the possible combinations of parameters. That is a strong indication that it is a code smell. There's another one in the bloaters category called data clumps. This is about grouping of data. Here we have the customer again, and the customer has a last name, first name, a middle name, a salutation, which is all fine. But here it starts to get problematic. The customer has a street address, a city, a state, and a country. And this can be problematic because it doesn't really belong directly to the customer. You can have customers that live in the same address, in the same building, or you can have customers with multiple addresses. So that is an indicator that this should be separate. And this is employed and is homeowner. This is also something that might seem like it belongs to the customer core data, but it's not. And also, you probably don't want all of your developers or people in your company to see this data. So again, this is grouping of unrelated data, which can be bad. This is one full category down already. We have 4 to go, and I hope you're still with me. Um, let's go to the second one, which is the object-oriented programming abuses, which applies more to object-oriented languages because this is about missing object-oriented design possibilities. This is a classic: switch statements. It's a method that branches out too much based on its inputs. In this case, I have a vehicles class with a number of wheels method. And yeah, I know it is a stupid method because you pass in a vehicle as a string and it gives you back the number of wheels that this vehicle has. And for this, I wrote this this weird switch statement here that checks if the vehicle is a car, it returns 4 wheels. If it's a boat, it returns 0. I actually did some thought here and put bike and bicycle, which both returns 2. And for all the other vehicles, it returns unknown. But you can see that there is actually a problem. This only returns only returns wheels for vehicles, nothing else. Whenever you have a new vehicle, you have to touch this number of wheels method. If it's in a separate class, if you have multiple classes that deal with vehicles, that can be really, really bad. And generally, again, this method is branching out too much, which is also harder to test. The next one in the OOP abuses category is called temporary field. And this is about field variables. So variables that belong to the class that are only used once. Actually, I struggled coming up with a good example for that, so I hope this one is okay. This is about a rectangle, and this rectangle has a method called getAreaSize. And an area size is just side A multiplied by side B. But if you look at this code, you might notice that side A and side B are here. That means in their initial state, both of those are 0. So if you create a new rectangle and then call the getAreaSize method on it, it will give you 0 because you haven't set the size yet. So here are the two set side A and set side B methods that actually set the length of each side. So what a user would have to do in this case is create the rectangle, call the set A and set side A and set side B methods to set the length of the sides, and then call the getAreaSize method. This makes no sense. This would require a lot of documentation for something that you could just fix in one line by creating the rectangle directly with the two sides. So this is, you see that the side A and side B, you have to set through methods, and they're only set for one specific method, the getAreaSize. I hope that was kind of clear, but it will get easier from from here on. I really like this name of this smell. It's called refused bequest. And yes, it is bequest. This is passing unneeded behavior to classes. What does this mean? So we have an animal interface. And when I created that, I thought, okay, animals can speak. So let's require a speak method for the animals. And for a dog that implements this animal interface, this is absolutely true. So I override the speak method of the animal interface and print out woof, because for me that makes sense that a dog goes woof. But then I got a requirement from a customer to implement a fish. So here, when you implement the animal interface and override the speak method, it does absolutely nothing because fish cannot really speak. That's what this is about. You have something in your interface that you pass down to class instances that is not needed. So this can point to code smell. Different interfaces, that's just a fancy name for the confusing naming of similar functions. And I have done PHP in my past, like many years ago, and I noticed this heavily in there. So here is a circle. We will get back to our friend the rectangle in a few seconds. This circle has a radius and it has a getAreaSize method. And this calculates the area size of the circle. We don't have to go into detail of how to do that. The thing that is important here is the method name getAreaSize. In the rectangle, this time we actually fixed it and pass in float A and float B, which are the two sides. It has the getSurfaceSize method, which does the same thing. It gets the surface size of the rectangle, but for a circle it's called area size, for a rectangle it's surface size. This just makes it unnecessarily harder for a user. And this is actually one of the code smells that are easiest to fix. Just rename the method and you're done. We are already in the third category, which is called change preventers. And change preventers are things in your code that hinder further development. The first one is called divergent change. And again, some of these code smells have very fancy terms. This just means that you have to do changes across methods. And for this example, I have an animal information class with a get Latin name method. And I'm doing the same strange thing as the vehicle class before. I pass in an animal as a string, and then I return the Latin name for that animal. In this case, horse, and it returns however you say the Latin name for the horse. And in any other case, it just returns an empty string. And then I have another method in this class, get number of legs, which again has the animal parameter as a string. And this returns the number of legs, in this case 4. For any other case, it returns -1. But you can probably spot the problem right away. If you have another animal, like, I don't know, a spider, you would have to add this to the first get Latin name method and to the second get number of legs method. Otherwise, you could run into problems if you just implement it in one place. And this for two methods, it might be okay, but in some bigger projects, there might be tens or hundreds of methods that would be required. This can also be found across classes when you have to make those changes across different classes. And there it's called shotgun surgery. Again, one of my favorite code smell names. You could imagine a shotgun loaded with a fix for something, and then you shoot it across your whole code base. I have a similar example here. In this case, I split the example from before into two classes. A classification class that has the get Latin name method for the animal that does the exact same thing, and a body parts class that has the get number of legs method. It's pretty similar, but here you have to make changes across classes. So not just in a single file, but across your whole code base. And modern IDEs will help you with this, but I wouldn't trust the IDE in any case that it finds everything. Parallel hierarchy. Sorry in advance, this is one of the two examples that are kind of hard to grasp, and I struggled a lot finding a good example here. It's about implementation of parallel interface hierarchies. Let me try to explain. Imagine you have a bird class and you have a specific kind of bird like a sparrow that extends this. So far, so good. And then there is an egg class. And you have a specific egg for the sparrow, which is a sparrow egg that might have some specific traits like color and size that is specific to this sparrow egg. And then inside the sparrow, you have a lay egg method that returns a new sparrow egg. So if you can see me on screen, you have the bird and you have the sparrow inheriting from it. And on the other side, you have the egg and the sparrow egg inheriting from it. So you have two similar hierarchies on both sides that you have to keep in sync in this case. So if you add another bird, you have to branch out both of those interfaces into a specific bird and a specific egg again. That can get really, really complicated and confusing. Well, we're we're getting along quite well. We are already at the dispensables. This is one of the easiest categories because this is about unnecessary things in your code that can most likely be removed. A lazy class is an example. It's a class that only has a single method. We have the web shop here again, and it has a class web shop checkout with just one method checkout. This is all. The thing is, this can be a code smell if a class does only one very tiny thing in a method, but it can also be desired. There are actually software design patterns that um, that need this, like a command pattern or a memento pattern. This is a design pattern for code or for functionality that can be undone. There, it makes a lot of sense. This is also what you have to keep in mind all the time. Is this a code smell? Does it point to a problem in your current context where you're finding this? Or might it be something that is desired for the functionality? A data class is another category here. It's a class that holds data belonging to it, but not the logic belonging to it. I don't know why I'm obsessed with rectangles, but apparently I am. There is this rectangle again with the side A and the side B. And here we can create one of those rectangles with a side of 5 and a side of 20. And the key thing that points to a code smell is here. We're getting the rectangle area by doing the multiplication of side A and side B again, but this is outside of the rectangle itself. This is done in the main method of your application. That means that when you need a rectangle area in any other place in your code, you have to duplicate this functionality again. It would be much, much nicer if that belonged to the rectangle itself. This is probably the easiest code smell to see. Also, IDEs and modern tooling can help you a lot with this. Duplicate code. It's the same code used multiple times. We are here in the customers class again, and in the add customer function, I have this line here to just give me an output of all the customers we currently have with a simple print statement. And I'm doing the exact same thing in the remove customers method in production code. By the way, I would never do that like this. Um, but the key is that you're using the exact same line here. And if you ever want to change how you log the customers, maybe to a log file or a database or wherever you want, you would have to change that again in multiple places, and would be much nicer to have that in a separate method that you can call from different places. That's a classic dead code. It's code that cannot be reached and will never be executed in your system. Again, IDEs can help you with that, or static code analysis tools. In this example, I implemented a getPy function that just returns the value of pi. But later, a colleague told me, wait, Java already has a pi constant that you can use in the math package. And from that point on, I used this, but I still have the getPy method down there. So this will never get used. Also, if you see this line here, the system out print line returning pi, if you've spotted this, congratulations. It's actually code that cannot be reached because it's after the return in the getPy method. So it's actually dead code inside of dead code. This is one of the things that um, I had many arguments about. It's about premature future proofing. I will get to this in a little while again. This code smell is called speculative generality. And again, we have an interface here, this time for a printer. And it has two methods to print some text and one method turn on or off. And here I have my laser printer class that implements this printer interface and then overrides these two methods. It seems all fine at first, but I only have one printer. So why do I need this printer interface at that point already? This is premature future proofing because it would make sense to only extract that interface as soon as you have a class, uh, another printer, another kind of printer, like an inkjet printer. But as long as you just have one, why have an interface? That just is something that I think is unnecessary. We are at the last category, which is called couplers. It's too much or too little coupling between objects in your code. This is feature envy. It's a class implementing features of another. It's kind of like the example with the rectangle and that didn't have the code to calculate its own area. Here we have an address, and this address is made of street, city, and country. And here, inside of the user is get address string, which returns the address as a string. And you can see that this string is constructed by using the address.street, address.city, address.country. So it's actually the user class providing this string representation of the address that should technically belong to the address itself. So it's a case of feature envy. I love this name of this code smell, inappropriate intimacy. It's about classes that know each other too well. Like this book. We have a book class which has an author, and we have an author class. And this author knows the book. So we have a circular reference here. We have a book knowing its author and the author knowing the book. Here, of course, a book could have multiple authors, and also an author could have written multiple books. So this is really inappropriate intimacy that shouldn't be, because it just ties us into this one relationship. Classic one that I do all the time, I have to say. Sometimes I like it and sometimes I feel guilty about it. It's message chains. It's returning objects that return other objects again, like here. You don't really have to look at all the code around it. Let's just imagine it's a storehouse, and this storehouse has a list of products and a list of shelves, and each shelf has multiple products, and products have descriptions. So, to get the description of a specific product in a specific shelf, we would do shelves.getZero, which would be the first shelf in the list, dot products.getZero, which is the first product in the first shelf, and then description. This is a method, a message chain, and this can be desired, but you have a lot of problems here because in each step of the process, you could get null values. So your code would miserably fail at that point. So it can be a good tool to keep your code concise, but it can also be dangerous. So you have to be really sure what you're doing. And when I'm not mistaken, this is the last code smell of the whole list. It's called middleman. It's a class accessing another one on its behalf. And we have the address and customer example again. After that, I will never talk about addresses or customers again. I will promise. The address is a street, has a street and a city, and the customer gets passed in the address. And then when we want to get the city from the customer, there is a get city method that just returns the city from the address. And we have a get street method that returns the street from the address. But you see what's happening here? The customer is cloning functionality of the address. It's just wrapping it in a method get city and get street when you could just call customer.address.city instead. So this is completely unnecessary to do this. So here we have it. We talked about all of the code smells here in all of the categories. There are actually more than these, but those are the ones from the book. I also have all the example code, all the classes and methods I showed you here in my GitHub repository. If you want to look at it again and maybe fix it, that would be nice. And for the last part, I would like to quickly talk about when to tackle code smells, because there are certain times in the software development lifecycle that are better to tackle those. Well, you might have heard of the broken window syndrome. It's about the long term effects of unfixed code. It's a theory um, that when you have a broken window in a house that is not fixed in the next days, people just get used to it and they might break other windows and eventually they might leave their garbage in the hallways. So this whole house is becoming a mess. This is not really proven in real life that this happens, but it is proven in the software world that this can be a really problem. Yeah, I just read, yes, it's mentioned in the book Freakonomics. Thank you, Paul. And it is can be dangerous if you just leave those things in the code and say, I'm going to fix them later, because other people will look at that code and say, okay, if code like this is in there, I don't feel guilty adding my own code that has those problems. YAGNI, which stands for You Ain't Gonna Need It. This is about the premature future proofing I talked about, wasting time with future requirements. If you remember the example with the printer and the interface, you save a lot of time if you do not try to make your code future proof. There is always time when it's needed to do this. Until then, it just makes your code harder to maintain for those cases that might never happen in the future. And the campground rule, that just means leave the campground cleaner than you found it. When you apply it to source code, it is if you work on some code and you find one of those tiny smells, maybe it's a good time to just fix it. Of course, not just fix it and push it, but maybe talk to the person who wrote it in the first place if it's okay. Because I know it from myself. If you say, okay, I'll make it work and then I'll make it pretty later, later will most likely not come because you will have other things to do. So, code reviews are generally a good time and a good place to point out those code smells before it's too late. I have talked a little bit about technical debt, and this is this is something you have to be careful with, of course, when you point those out, because you need to be very polite. Don't just say, haha, I found something that might be wrong, but really talk about it with the developers and say, yeah, maybe I found an inappropriate intimacy here. So everybody knows what you're talking about, and then fix it. Yeah, some more information if you're interested what you can do to fix those smells. There is the refactoring catalog under refactoring.com/catalog. That is actually the site that belongs to the refactoring book, which has a lot of information about how to fix code smells, what strategies you can use. Rather useful. Then there is the Refactoring Guru website that has similar kind of content, but it just looks a little nicer. And it actually uses the categories and the taxonomy of the code smells that I showed you. And this one is a really nice website from Marcel Jesik. It's under this github.io address. And he actually created a website that you can filter by specific smells. And he actually wrote a thesis about code smells. So there's a lot of valuable information in there. And because I was kind of inspired by the talk before mine, I tried to find a quick example using Microsoft Copilot. Um, I will not do that live, but trust me, it does work. I just gave it the first example code snippet um, and asked it which code smells can you identify in this code. And when I did this, it actually generated, I think, 2 full pages of text and a lot of information that were not really useful. But let me also say that this prompt, which code smells can you identify in this code, is very, very short and not very specific. So that's all right. But what I want to show you is this part of the answer was the fifth bullet point: single responsibility principle violation. The save customer method is doing two things: saving the customer and creating a message. It would be better to separate these responsibilities into two methods. Bingo. It actually pinpointed the long method code smell. It didn't really say what it was, but it directly gave a hint of what could be better about that method. And this is the power of these AI tools that you can just talk to it like a fellow developer, and together you can just figure out a good solution. Yeah, I just, for myself, I needed to show that smelly code slide again. And with this, thanks a lot for listening to me and listening to all my ramblings about code smell. And I hope there was something in it that was valuable for you.
Benjamin, that was fantastic. I believe I am guilty of quite a few code smells inside of that we had there, and I gotta tell you that the Copilot is fantastic. I mean, that's just a blessing uh,
Yeah.
for anyone who's working in coding, whatever your IDE happens to be. If it, I think Copilot is supported in Visual Studio Code. Um,
Yeah.
I believe there's also an AI add-in if you happen to be working in like JetBrains tools. There's also an AI tool in there for checking your code and stuff.
Yeah, actually, I use all of those. I use the Microsoft slash GitHub Copilot in VS Code in IntelliJ IDEA. I know JetBrains also has an own AI tool that I haven't tried yet, but I also use the Copilot that is a part of the Bing search engine, also ChatGPT, and yeah, always playing around with those tools. But so far, I have to say the Copilot integration in the IDE is the most powerful for me because it can actually look at the code that you have in your project, which is just incredible.
Yeah, I love it, especially when it gets. In fact, on that last demo, you gave showed the recommendation of how to improve what you've already got in there. I get that a lot as well. I wanted to circle back around to campground rules, where never later never comes.
Yeah,
Um, I think it may lead to something that I've always called, which is called the pony um, requirement, the pony list, which is basically when I put in a request for a feature or change and it's deemed so low that it's so low on the list that I'll get that pony I wanted for Christmas before this thing is going to get fixed. Essentially becomes, yeah, we'll fix it later. Like later, it never comes unless you get somebody who's like really pushing for it. Listen, I know it seems small, but please get it up there so that we make everybody happy.
yeah. What you can actually do in your team is have sessions like paper cutting sessions where you just focus on fixing those very small things, like in an hour or two. That is really valuable, just to get rid of those code smells, and it's really satisfying too.
uh, I'm going to go do that. Introduce that on my current project. Um, I also like you were mentioning Yagni. You ain't going to need it. I've seen situations where this is kind of the opposite, where the feature is so uh, interesting and cool, but they won't release it until it covers like 100% of everybody's expectation. And
Yeah.
it's like it's getting 90%, 95% of everybody happy. Let's get it out there. And they're like, no, we still got that 5% we got to cover. We got to figure out and think about, no, just put it out there. If you figure it out in if you figure it out in 2 months, 3 months, okay, cherry on top of the pie, but give me the pie, man.
Yeah, and this is exactly what those things like feature flags and CI/CD pipelines and continuous integration is for, to just push out stuff and then make it better over time, and
Yep.
not wait and release it maybe after other companies release something like
Yeah.
this.
Yep.
Yeah.
Uh, you also mentioned dead code. Uh, I actually worked on a project at one point where uh, it was one of my first automation projects I did on a X-ray machine, and we needed to find the requirement came out that says how much of our code is actually testable, how much do the manual testers hit? How much does the automation hit? So I wrote a recursive crawler that just basically on the first page grabbed all the links and went, let's go to the next thing. And they turned on and by the way, this was 20 years ago, so I'm sure it's much faster. But they turned on the tracker to see how many lines of code got touched by that stuff, and they said, "Oh, you're only hitting 80%." But then one of the developers came by and said, "The other 20% is all inside this function. We wrote it, but we don't call it anywhere, so it's unreachable." He's actually getting closer to 95% coverage on the whole thing, and pointed out some areas where we have made a small, just haven't gone far enough on that.
Yeah, and
Anything? Go ahead.
yeah, if you use source code versioning systems, there is actually no need at all to leave any code that you're not using in there because you have it available all the time. The same is can be said for documentation. Don't leave documentation in there of things that are not there.
Yes, definitely. That is one of the things I do like also about ChatGPT and Copilot is that one of the things we always leave off, and this is like never later never comes. I will document this later. Uh, Using ChatGPT to go, please go write the headers for my functions, go document whatever needs it. That is an amazing time saver and makes things so much easier, especially
Yeah.
if you have to look back at the code, 6 months later and go, man, I was brilliant back then. What the heck was I doing? I wish I documented it.
Yeah, and I always say no documentation is better than outdated documentation that leads you down a garden path. So
Yeah. I have some good news for you. I did post the link to your book, Writing API Tests with Karate, up in our chat over there. If anyone
Mhm.
wants to get it. And the other good news is that you have a new sale because while I was watching this, I went and picked up a book. It should be arriving at my front door um, in a couple of days. So I'm going to go
Cool.
write it. You and I have the exact same publisher, Pack Publishing. So we're really happy to have them and promote that. Um, so we got about 3 minutes left. Um, I'm trying to think of other things. I guess I wanted to. There isn't a lot of questions over here, so I'm just kind of asking a few things. The one thing I wouldn't quite catch is the inappropriate relationship slide
Yeah.
that you had up there. If we could have our back guys, can you share Ben's screen so you can go back to that slide? I I wanted to see if we get a little bit better understanding of what that was about, and let's see if our backstage runner can bring up our slide, our shared screen for Ben, or he's taking he's an afternoon tea. Oh, Ben, you guys share. He's saying Ben, share your screen.
Oh, I'm not sharing anymore.
Yeah, I think it automatically cuts it off once it gets shut off. So try one more time. Let's see. There we are. Yeah, give me a little bit more about what was going on there, if you don't mind.
Yeah, the book class and the author class. Usually, you would have a relationship of a book with authors or an author with books. But in this case, we have both. We have a circular relationship of the author of the book that knows the author and of the author knowing the book. This is again something that can be desired in like ORM systems um, that deal with databases and database abstraction. If you have this circular dependency, but in most cases this is not needed. You would have a book class and an author class, and you would have a third class that connects those two.
Gotcha. Okay, cool. One of the other ones I saw, you can look on Wikipedia. There's a list also of bad code programming anti patterns. If you look on Wikipedia, there's bacon wrapped in ham, which is essentially rewriting a function and wrapping another function that just calls the other function.
Yeah.
Um, very rarely do I have a use for that, but it kind of makes me chuckle when I see that. Ben, I gotta say, thank you very much for joining us on the Zappletech meeting. It has been a great pleasure, a great learning experience. I gotta go fix a bunch of my code, or I'll have ChatGPT or Copilot go fix it for me. Any last things? Any way if you want to have people talk to you, communicate, or is there any website or anything else you might want to share?
Yeah, the easiest way is to go to my website, softwaretester.blog, which also lists all my social media contacts. It's just down there, written on the slide. And this is where I also
Ah,
occasionally have articles about software tests and code craftsmanship.
perfect. Well, again, Ben, thank you very much for your time, and we definitely will invite you back to share more insights on stuff. Good luck with the book, um, and
For you too.
thank you very much. Yeah, if didn't quite catch, there it is. The also by Pack Publishing, enhanced test automation with WebDriver IO. Give that a plug over there. We will have another session next month in March, February, March or April. We'll probably have Larry Goddard come back. Larry is my co-author on that book as well, and he's always fun to have to do these sessions. I'm always happy to be here and take some time, and it's an easy way to learn all sorts of new stuff. So I'm going to say on behalf of Zappletech and Ben, thank you very much for coming, and Jan as well. And we do have this session recorded. It should be on the YouTube channel right after we're done here. And everybody, have yourself a great day. Stay safe and keep automating. Cheers.
Thanks for having me. Bye.